Today we will study about a specific heat capacity, the quantity of heat required to warm a given substance depends on its mass in the change mass m, the change in temperature delta T, and the nature of the substance. The change in nature of substance when a given quantity of heat is absorbed or rejected by it is characterized by a quantity called the heat capacity of that substance. We define heat capacity as of a substance as S barabar delta Q by delta T. When it is the amount of heat supplied to the substance, the change its temperature from T to delta T. When delta Q is the amount of heat supplied to the substance, I change its temperature from T plus delta T. If equal amount is added to equal masses of different substances, the resulting temperature changes will not be the same. It implies that every substance has a unique value for the amount of heat absorbed or rejected. To change the temperature of unit mass of it by 1 unit. This quantity is referred to as the specific heat capacity of the substance. If delta Q stands for the amount of heat absorbed or rejected by the substance of mass m when it undergoes a temperature change delta T, then the specific heat capacity of that substance is given by S is equal to S by m barabar 1 by m delta Q by delta T. It is equation number 2. The specific heat capacity is the property of the surface which determines the change in the temperature of the substance undergoing no phase change. When a given quantity of heat is absorbed or rejected by it, it is defined as the amount of heat per unit mass absorbed or rejected by the substance of change by 1 unit. It depends on the nature of the substance and its temperature. The SI unit of specific heat capacity is joule per kg per Kelvin. If the amount of substance is specified in temperature of moles instead of mass m in kg, we can define the heat capacity per mole of the substance by C is equal to S by mu, 1 by mu delta Q by delta T, where C is known as molar specific capacity of the substance. Like S, C also depends on the nature of the substance and its temperature. The unit of molar specific heat capacity is joule per mole per Kelvin. In case of gases, additional condition may be needed to define C. In this case, heat transfer can be achieved by keeping either pressure or volume constant. Then it is called molar specific heat capacity at constant pressure, denoted by Cp, and molar specific heat capacity denoted by Cv at constant volume. Now the calorimetry is measurement of heat when a body is at higher temperature. It is brought in contact with another body at lower temperature. In that case, heat lost by the hot body is equal to the heat gained by the colder body. So the heat gained is equal to heat lost. On this principle, we measure the specific heat capacity of the liquid or the substance. Now the change of state. Matter normally exists in 3 states: solid, liquid and gas. A transition from one of these states into another is called change of state. 2 common change of states are solid to liquid and liquid to gas or vapor. These changes can occur when the exchange of heat takes place between the substance and its surroundings. As shown in the figure, the graph between the temperature and time. In the figure 1, the change of a state from solid to liquid is called melting, and it is called fusion. Now at atmospheric pressure it is called normal melting point. Similarly, the phenomenon of refreezing is called rigidation. Skating is possible due to rigidation. The snow or ice turns into water. It again freezes into a snow. So we can skate on the hilly area or ice area. Now, the normal boiling point is the temperature of water turning into vapor or liquid turning into vapor. It's called, at atmospheric pressure, it's called normal boiling point. Similarly, when any substance is directly converted into gas or vapor from solid, it is called sublimation, and the matter is called sublime.